What's up, Mr. Messers, geometry students? Sorry I'm not there, but you're still learning stuff today. And this is a lesson that I'm a little bit sad that I'm not there teaching you because the discovery of what we're going to be talking about today is the fun stuff. The formulas that we will be using, boring, and I don't know. I feel like I'm going to try to give you an appreciation for the sphere and its relationship to the different objects that we've already talked about, a cylinder and a cone. Okay. So we need to watch this video first. And Sub will put this video on, pause this video, and then we'll talk about what you just saw in the video. Okay, ready, set, go. Pause my video and start the other YouTube video. Cool. So, what the guy was trying to explain is how Mr. Cool Mathematician, OG Cool Mathematician, Archimedes, discovered that if you take a cylinder that can perfectly fit a sphere, okay, that the volume of this cylinder equals the volume of the sphere that fits inside plus the volume of this like double topped cone. And this was potentially based on intuition, where he's like, I bet you that if I look at any section, that the area of this cylinder will equal the area of the sphere, which is going to be smaller because it's curved in. And then the area of like this part of the cone, which is very small, but like this area plus this area equals that area. Cool. And we are going to investigate that. Now, the first thing we're going to do is label the characteristics of the cylinder and the cones based on the fact that we know this sphere has a radius of r. So what I would like you to do is tell me, what is this length here if this sphere fits perfectly into this cylinder? I also would like you to tell me what this length is here. So go ahead, and you and your neighbors label this, and then label this length as well. I'm going to be like pausing during this video, and I expect you to work. So if you're just like waiting, stop waiting. Your laptops also should be closed. You don't need your laptops here. Okay. Hopefully you think that, oh, well, if this sphere has a radius r, well, this length is r, that length's r. And if this fits perfectly inside this cylinder, that means this is actually like the circle on the top and the circle on the bottom. So you should have labeled this as r and this as r and another r, or 2r. Cool. Cool. Then what about this? Label this length here, this length here, as well as this length here, and this length. Check with your neighbors. You should get that. Okay, we have these two cones that have a height and a radius that are the exact same. Here we have a cylinder whose height is double the radius. Here we have a sphere, consistent radius. Okay, now I'm going to have us check that this kind of part of the video right here, where he's like, hey, we understand the top of the cylinder will equal the top of the cone, and we understand that the sphere has like no area at the top. And understand that at the middle, that'll equal the middle of the sphere, and then there's nothing in the cone. But the question is, what about at some place else? What about like any other location? Will we have this idea of this area of this circle equals this area, this cross section of this sphere, and this cross section of this cone? We are going to investigate to ensure that this is true for one location. And we're going to then assume that it's going to be true for all locations, which is not very mathematical, but it's okay with us. And we're going to do some math. So we are going to check that the area of this circle equals the area of this circle plus the area of this circle. We are going to make an assumption that the radius of the cylinder is 10. We're going to make the assumption that we are halfway up the top part of the circle. Cool. Now, step one, let's find the area of this circle in the cylinder. What is this length right here? And then what would be the area of the circle? Ready, set, go. Check with your neighbors. Great. This is 10. The area of a circle is pi r squared. So the area of this circle is 100 pi. Now, these circles are not so easy. So we need to do a little bit of math. Now, the first circle we're going to look at is the circle inside the sphere. Our goal is to find this radius length right there when we are halfway up our circle. We need to find this pi r squared. Well, it's not going to be 10 because we can see it's less than 10. We're halfway up. So we know that all the way up is 10. We're going to go halfway up to 5. The question is, how do we find the radius of this length? I'd like you to try to figure that out. And I'll give you a hint. It's a sphere. Spheres are special because it's all of the points in all 3 dimensions that are 10 away from the centralized point.
I have one other friend.
So, how can you use that to your advantage? Ready, set, go. Figure it out. You still don't see it. Here's your massive hint. This length is also 10. Which means if this length is 5 and this length is 10 and this is a right triangle, I can use the Pythagorean theorem to find this length here. This is the hypotenuse, so this is 10 squared, which is 100. This is a height of 5, so this is 5 squared, which is 25. 100 minus 25 is 75. This is root 75, and you know what? I'm just going to leave it as root 75, even though it's 5 root 3. But you know, that's an interesting thing. Turns out halfway up the circle, this is a 30, 60, 90 triangle. If you recognize that it's a 30, 60, 90 triangle, good on you. Now you could simplify this to be 5 root 3, but I'm going to leave it as root 75 because what is going to be the area of this circle whose radius is root 75? Let's go ahead and figure that out. Well, if I take root 75 and square it, I get 75. So, bam, 75. Pi is the area of that circle. Cool. So we have the bigger cylinder, we have the sphere that fits perfectly inside the cylinder, and then we got this cone that also kind of fits nicely in the cylinder. And now our last goal is to find the area of this circle. And again, what we have to do is find this length. Now, this one is actually the trickiest one to consider. What is this length here? What is the radius there? And I am going to give you a hint. We know that if this length is 10, that this length to the middle is also going to be 10, and all the way up to the top will be 20. So cool. This length is 10, this length is 10. What would happen if we look at any other point making this other triangle? What do we think this length is and why? Ready, set, go. Take a guess. If you're not participating, I'm a little disappointed. You know who you are. I believe that you guys can figure this out. Cool. Well, if this is a 10 by 10, this triangle is similar. That means the side lengths are going to be proportional, which means we don't really know the hypotenuse and we don't need to know the hypotenuse. We can't say that it's 10. We can't say this is 75. Rather, we know that if we have a triangle that's a 10 by 10, this triangle has to be a 5 by 5 right triangle. They're going to be isosceles right triangles. They are similar to each other. So that's very interesting that we always have this, no matter what the height is, the radius will equal the height for this shape. Now go ahead and find the area of this circle right here using pi r squared. Well, we just discovered and confirmed what the guy was saying. Archimedes then maybe used water to show these were equal, but I'd actually probably use math to show that they were equal at all locations because it's easy enough to do. And he was a genius. We showed that the area at a cross section of a cylinder equals the area of a cross section of a sphere plus the area of the cross section of this double topped cone. Great. Well, that is where we are going to kind of go with. This is what we're going to go with to find the formula for the volume of a sphere. We are going to start with the formula for the volume of this cylinder, and we'll have the volume of these two cones, and we'll then find the volume of a sphere. So please tell me, what would be the formula of the volume of the cylinder if this is R and this is 2R? And try to simplify it for me. Check with your neighbors, go. Don't be afraid of using letters. It's the area of the base times the height. Cool. I got pi r squared times 2r. I'm going to move things around and say it's 2 pi r cubed. So that's the formula of the area of this cylinder that that this sphere perfectly fits inside, so that the height is 2 of these r's and the radius is r. Now let's come over here to the cone. Let's just look at the top cone. What would be the volume of the top cone? Actually, let's look at the bottom cone. You guys are more used to looking at the cone in this orientation. Well, do you remember the formula for the volume of a cone? Well, it's 1/3 the area of the base times height. So write that down. 1/3 the area of the base times the height. So that's 1/3 pi r cubed. But I have 2 cones, so I need 2 of these. So I have 2/3 pi r cubed. Well, now the question is, what is the formula for the volume of the sphere? Which we don't know, and maybe you remember it from middle school, but you didn't really know why. What must this be if this plus 2/3 pi r cubed equals 2 pi r cubed? How many more r cubes do we need? How many more pi r cubes do we need to take these 2/3 pi r cubed and make these 2 pi r cubed? Well, 2 pi's are like 6/3 pi r cubed. You could actually use algebra and subtract, or you could realize, oh, this has to be 4/3 pi r cubed. My friends, this is the formula for the volume of a sphere. In other classes, probably in middle school, you're just told this is what it is. Maybe you did some investigations, potentially using sand, potentially using water, but we tried to do this mathematically. And hopefully you appreciate the discovery of the formula using shapes that we are familiar with. Cool. Now we're going to move on to surface area. I need you to go ahead and watch this animation that shows how the surface area of a sphere relates to the surface area of a cylinder. Go ahead and see if you can visualize that by watching this video. And I'll wait a little bit. Pause this video. Watch it. All right, it was a really cool demonstration. I don't know if you can see what I'm showing, but kind of unwraps the sphere, and then it shows how if you flatten it out and then just cut off the tops, take the part over the top of the height. So it's like you take your sphere, you then just look at the top and the bottom after you unroll the outsides. You like cut it off and you move this top and the bottom to the outsides. You realize that it fills in perfectly a rectangle. And that rectangle, when wrapped around the sphere, the rectangle actually creates this middle part of the cylinder that we were talking about, the cylinder that the sphere perfectly fits inside. So we don't have the top, we don't have the bottom, we just have the middle. So the surface area of a sphere here is equal to just the middle part of the cylinder's area. Now let's figure out again, what is the characteristics of this cylinder, and then let's find the formula for the area of this rectangle when it's unrolled. So please label what is this radius and what is this height. If this is a sphere that fits perfectly inside the cylinder and the sphere's radius is r, which means it's r and r, cool. This is r, this is 2r. Unroll the middle part of your cylinder where the sphere perfectly fits inside. What are the dimensions of this rectangle, which is the cylinder unrolled? The height is still the height. This is the perimeter of the circle. Multiply those together, you get 2r times 2 pi r. Move things around, 2 times 2, r times r, 4 pi r squared. This, my friends, is the surface area of the sphere. It's just equal to the lateral area of the cylinder that contains the sphere perfectly. All right, so like in the end, the lesson is easy. If you were just told, here's the volume of a sphere, here's the area of a sphere, but I don't like it as much as like discovering this, not just being told this. I hope you appreciate this kind of discovery and these connections of this new shape, the sphere, with shapes we already know about. And that's the connection that Archimedes made so many thousands of years ago. Okay? The rest of the questions that you will have will involve you using these formulas. You're asked for the volume and the surface area. Well, all you need is the radius. The volume would be 4/3 pi times 12 cubed, whatever that number ends up being. Area would be 4 pi 12 squared. No big deal. This is interesting. The diameter, the volume. Okay, well, I'm going to set up an equation. I know the volume of a sphere is 4/3 pi r cubed. I know the volume is 36,000 pi. I want to find what is the radius. So we're going to have to do a little bit of calculations, and I actually need you to learn how to find what is called a cube root. It's like a square root. So let's solve this equation. I'm going to divide by pi on both sides. Going to multiply by 3/4, which will get rid of the 4/3. So I multiply by 3, divide by 4. Let's get out our scientific calculator or your calculator, your graphing calculator. I'm going to get out the graphing calculator so I can show you what it looks like on your graphing calculator if you're using it. So I got 36,000 times 3/4. I get r cubed. Oops. 6,000 times 3/4. 27,000. Let's say you want to figure out what number times itself 3 times gives you this number. What we're going to do is called a cube root. Now, a cube root is like a square root. It's actually equal to a 1/3 power. So what I want you to do is actually take this number, 27,000, and instead of like finding what the cube root button is, I want you to take it to the 1/3 power. And a 1/3 power is essentially equivalent to a cube root. Just like a 1/2 power is actually the same as a square root. Now, many of you probably could have figured out that it was 30 because 3 times 3 times 3 is 27. But just showing you how you can use your calculator to get this value. Now, watch this. If I did 9 to the 1/2, this is the same as the square root of 9. If I did 36 to the 1/2, this is the same as the square root of 36. If I do 27 to the 1/3, I get that 3 cubed is 27. If I do 64 to the 1/3, I get that 4 cubed is 64. So if you're ever unsure what the value is, we're going to use a cube root. Okay. The other question we have as an example involves a composite figure, which is always interesting. We got a cylinder with a circle on the bottom. We got this, the rectangle. If I unroll it, I got half of the sphere up top. Okay. And then your homework is delta math, which if you have time during class, you could do. Let's do the surface area. So I got the area of the bottom, I got the middle, and I got the top. Go. And then do the volume. Go. We actually moved your test back. Your test is not going to be on Wednesday. It'll be on Friday. We have one more lesson. And then a review day Wednesday, then a test on Friday. All right, we got the bottom, pi 6 squared. We got the middle. The middle is a rectangle, height 9. This is going to be 12 pi, so 9 times 12 pi. Whatever that is. $108 pi. Then we have half of a 4 pi r squared. Remember, the volume of a sphere is 4/3 pi r cubed, 3 dimensions, units cubed, but an area, 2 dimensions, r squared, 4 pi r squared. So I have 36 times 2, which is 72 pies. So I have 108 plus 72, which is 190 plus 36 is 126. I think my answer is 126 pi. Just double check that really quick. Oop. That's why I'm not. 216. Ooh, that was bad. What was I thinking? 126? I think I just flip-flopped some numerical dyslexia out there, which is okay. Okay, volume. I need the volume of the cylinder plus the volume of the half sphere. Notice this is just the circle on the bottom. This is the rectangle in the middle, and this is the half sphere. The cylinder is pi r squared. times 9. The half sphere is a half of a 4/3 pi r cubed. Fine. Let's do those calculations in our calculator. Nine times 36 is 324. 6 cubed. Use the caret times a half times 4 divided by 3.
Yeah.
32 plus 144. Bam. Okay. All right. Homework's Delta Math. We have another lesson actually on Monday. We will have an entrance ticket on this stuff on Monday. Hope you appreciate the connection between objects that we have learned about and this new object. And appreciate the learning process versus the just tell me the formula, just not as fun. Okay, cool. I will see you guys on Monday. Thanks for being good to the sub. Peace. Do your homework. Peace.